Hello, this is Ramesh Abhiraman and welcome to another edition of Fun Math. Today we are going to start with a little quiz. This is about a sequence of numbers and each subsequent line is derived with a rule from the previous line. You're asked to guess what is the fifth line. Please pause the video here and take a guess as to what the next line is. If you have come back after the pause but have not been able to find out and you're curious, I have added another initial sequence. This sequence is also generated by the same rule as the first sequence. I still haven't told you how the rule operates, but I've given you another chance with the starting sequence 3 and the next two sequences as shown. You're now required to guess the fourth item in that sequence. Again, please pause the video or copy it down on a piece of paper and come back to when the solution will be revealed. Okay, to those of you who are able to get the next item in the sequence, congratulations. To those of you who just wanted to see the answer, here is the answer. For this, the next answer is what is going on here? Well, this sequence has a very simple name. John Conway, the mathematician, called this the look and say sequence. This involves no higher math. A child could do it. What you do is you look and you say, what is this? 1. How many ones? 1, 1. That's what the sequence is. 1, 1. That sequence in turn is 2 ones. What is this now? If you look and say 1, 2, 1, 1. And then you can figure out the next one in that sequence because you need to look and say 1, 2. Sorry, that's just 1, right? 1, 1, 1, 2, 2 ones. Now, with 3, it's 1, 3. Look and say 1, 1 and 1, 3. But now when you look together, how many ones are there? There are 3 ones. So it's 3, 1, 1, 3. Now, the first bit of magic. You see no 4 if you start with any sequence that comprises numbers only 1, 2, and 3, and you do not have a sequence of 4 ones or 4 twos or 4 threes. So no matter how far you go down the line, there is no reason by which a 4 will ever appear when you look and say. Now, don't take my word for it. Start with various sequences. You can start with, say, 2, 3, 3, 3, 1, 2, 2. Now, this obeys the starting rule that there are no 4 consecutive numerals of any kind. We have only used 1, 2, or 3. And you go on and look and say. It's going to get a little cramped, but we will try and look and say what happens to this sequence. 1, 2, 3, 3. 1, 1, 2, 2. Sorry for my writing over here. Let's make this a little more legible. 1, 2, 3, 3, 1, 1, 2, 2. Let's describe this. Look and say, you have 1, 1, 1, 2, 2, 3, yeah? 2 1s and 2 2s. Sometimes the length of the sequence just explodes, but sometimes it doesn't. Now, is there a rule? Question. What is the length of the nth sequence? For those of you who are inclined to do more quantitative thinking, start with various sequences and see if you can come up with a blow-up factor of what the nth sequence will become in length. There are some surprises here, but I wouldn't like to spoil your fun as you go in and play with numbers. That's the best way you can get fun out of math, instead of taking everything from the person who has already investigated this at length, like Professor Conway. Now, here, the next line here would be 3 1s, 2 2s, 1 3, 1 2, 1 1, 2 2. I would just like to go on for another couple of lines here because I'm trying to see something about front end rhymes and latter part rhymes, similar to pentameters or similar to Sanskrit poetry or Tamil poetry. You like to see how the end rhymes with itself and out after how many lines. This is becoming some kind of a verse, and I will tell you what I mean in a little bit. Perhaps you can already look at some patterns. 1 3, 1 1, 2 2, 1 1, 1 3, 1 1, 1 2, 2 1, 2 2. And again we go 1 1, 1 3, 2 1, 2 2. Let's not go any further. I'll do the next one here. 3 1, 1 3, 1 2. Now, here is what I mean by the front syllable alliteration and the rhymes of the last syllable. If you look at this, oh my God, the end is frozen. They're all rhyming. It's all 1 2 2. And if you look at the front here, after a while, we arrive at a cycle. It's 3 1, 1 3, 1 1, 3 1. Again, please pause the video here, start with any seed sequence and investigate the periodicity of the tails and the periodicity of the front. We will now take a short commercial break, and when I come back, I'm going to tell you what Professor Conway discovered with these look and say sequences. I will also introduce an alternate name for these sequences, which was extremely witty, profound, and is full of the most amazing coincidences ever known to mathematics. Back after this commercial break.